Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and AEP SPAN. My name is Stacy Ranella. I'm the editor-in-chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folder. If you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you are experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now I'd like to introduce our speaker, Jeff Medeiros. Jeff is the architectural representative for AEP SPAN and is a licensed contractor who has been supporting architects in California for more than 20 years. Jeff can spec write, assist in detailed drawing, and aid in product selection, or any aspect of the design build process from initial design to complete bid-ready documents. He's fluent in building code, bid laws, and contract code. He provides architects with a full range of services from conception through bid. He holds various degrees, including law and society from UC Santa Barbara, Japanese from Waseda University in Tokyo, and he attended McGeorge School of Law in Sacramento. He's fluent in all types of roofing systems, built up and torch applied hot and cold process, and restoration coatings such as silicone urethanes and acrylic single ply roofing. He is also fluent in all forms of metal applications, including roof wall coping and soffit, as well as flashing trim. Jeff made the move to AEP SPAN over 7 years ago after spending years with a competitor and plans to stay on through retirement. In this webinar, Jeff will discuss material inputs and performance attributes of architectural single-skin metal siding and the product testing, specification, and installation considerations that impact project requirements. We'll learn how quality material and product attributes contribute to a successful single-skin metal project. Jeff, we appreciate you joining us today. Please take it away.
Good morning and/or afternoon to everyone. How's everybody doing today? All right, this is on single skin metal siding. Did not move to the next slide. There we go. This is the screen that I've got to show you to get your continuing education credit, 1 CES. Moving on. So we're going to talk about single skin metal siding today, okay? And what I want to focus in on is single skin metal siding does not include anything else that has insulation behind it like IMPs and so on. Single skin metal is just that. It is a piece of metal installed as siding. So we're not going to talk about anything insulation-wise in this. Topics today are going to include material, performance, paint, environment, sustainability, and how to install single skin metal siding. This slide's boring. Let's skip it. All right, learning objective 1. Let's talk about paint, okay? So when a coil comes in, so imagine a roll of toilet paper, okay? Now make that roll metal. Now we're going to turn it on end, eye to the sky, and make it 4 foot in length, okay? 4 foot in height. That's a metal coil. It's a huge metal coil that they transport on the back of trucks. If you're ever behind one, get out of the way. It's not safe to be behind whatsoever. That metal comes in and it's quote unquote bare. When it comes in, it's then treated or coated with a different coating depending on which way you're going to go. It can go galvanized, it can go zinc aluminum. For steel, there's also aluminum. So when it comes in, the first thing that happens is that coating. I believe it's on the next slide. There we go. So zinc aluminum galvalume is what my company uses. That's a 55 to 45 aluminum to zinc coating. All right, zinc aluminum galvalume, same as tissues, Kleenex. Same thing, different trade names, okay? The aluminum 55% provides the barrier protection. It's inert, doesn't corrode, right? And the zinc is the sacrificial characteristic, that's like galvanized. So your G60s, G90s, and so on is 100% zinc. Those don't have a warranty. So a takeaway for everyone here, not all metal substrates are the same. Once that big roll comes in, that big coil, and it gets coated, if it gets coated and galvanized, which is 100% zinc, it does not have a substrate warranty. This is industry-wide. Okay, Zincalume Galvalume does. So even if that coil comes in and they coat it with Galvalume and you want it to be non-painted, so it looks, DC-3, 1970s airplane-y American Airlines, right? So it looks like bare metal. There's a paint finish warranty, no paint warranty. There's a finish warranty with that because it's coated 5545. Aluminum, of course, does not require a warranty because by definition, aluminum is non-corrosive. So something to keep in the back of your mind there. Not all metal is the same. So if you're looking at a bid and you go, hey, why is this 20 cents more expensive per square foot? Look at the base substrate. It might be different. So when it comes in, it coats with Zincalume Galvalume, and then the paint goes on. Okay, the Zincalume Galvalume and or galvanized coating, if you go that route, acts as the substrate that the paint bonds to. Okay, I think I've got a paint system over here somewhere. This is the clear coating. Here's our paint systems. Okay, so after it gets coated with Zincalume Galvalume or G90, it goes through paint. So polyester is not a very good paint system, right? You can scratch it. That's what most oil coaters put on the back of the panel. It's white, it's not exposed, very cheap, easy to do, right? SMPs is the next step up. Silicone modified polyesters are used on light gauge metal. So if you have like a 29 gauge or a 30 gauge or a 28 gauge or a 26 gauge type product, that's typically silicon modified polyester. And here's why. So imagine a piece of paper. If you hold it up, it'll flex and it'll move, right? That's what light gauge metal does. Lighter gauge metal flexes and bends and moves. And so if you put a fluorocarbon, like a PVDF, Kynar finish paint on it, that's more brittle. It's going to crack and craze. So because that metal isn't as strong, as thick, an SMP must be used. For your thicker gauges, your 24, 22, 20, 18, and up, that's more like cardboard or cardstock, right? It'll move, but nowhere near as much as a piece of paper, like for the lighter gauges. That you can use Kynar on. But even when you use Kynar, the back is usually a polyester paint. I'm going to go off track right here real quick. So when you're specifying something, make sure that you say that all sheet metal flashing and trim, including flat stock, shall be sourced from the same manufacturer as the metal panels in order to, number one, maintain an exact paint system and color. And number two, a congruent paint finish warranty. So for example, the polyesters carry maybe a 5-year warranty, SMPs carry a 15. Kynars can go up to a 40-year paint finish warranty now. And here's why you specify that. So your contractor, your sub, can't go to ABC Supply, RSG, Roofing Supply Group, Diamond, whatever supply house they want to go to, and buy a polyester paint system on flat stock in quote unquote royal blue, right? Or cool royal blue. And the rest of your panels are 22 gauge Kynar cool royal blue. It's not going to weather the same. So you're going to have flashings and things that are made from flat stock that are going to weather, and it's going to turn from royal blue to a light baby blue pretty quick, and the rest of your roof will look just perfect as the day it was installed. So make sure your sheet metal flashing and trim is sourced from the same coil, from the same manufacturer with the same paint system. Don't let them go cheap. Moving on. I think I just talked about all this actually. So cool paint systems. So when you see the word cool, again, I'm going off these slides. When you see the word cool, I want you to picture Tinkerbell. Okay, yes, I said Tinkerbell, the magical fairy from Peter Pan. Okay, you know how when she flies, little things come off the back like her magic fairy dust? That is what I think of when I think of cool, because some chemist who was way smarter than me came up with a magic fairy dust that doesn't change the pigment to sprinkle into these coatings that drops the overall SRI value. Again, it is legitimately a magic fairy dust that is added to these paint tanks, doesn't change the pigment, and it drops the SRI. So when you see cool royal blue or cool regal white, it's the same color as regal white or royal blue, but it has that pigment, the magic fairy dust that doesn't impact the pigment. And that's what makes it cool. It drops the overall SRI. All right, so PVDF, we talked about polyesters, that's the cheap, SMPs, PVDF. PVDF is your Kynar, your Hylar, 70% Kynar pigments, right? Paint systems. Gonna go off track again here. Kynar, you may start to see an impact on Kynar colors. The reason for that is because the chemical that is used in Kynar paint is also used in EV batteries, and it separates the positive from the negative side. It's that barrier. So the paint manufacturers like PPG and so on don't have the same pull as Tesla or Toyota. So as EVs become more popular, unless a different battery technology is developed, that same resin, that same Kynar resin that is used in the paint is also used in the EV batteries. And so I'm starting to anticipate that over the next couple of years, when these become much more common, the cost of Kynar might raise. So you may see Kynar paint go up in cost. Again, this is off topic. It's just something that's happening in the vertical right now with competitiveness to secure that resin. Anyway, getting back on track. PVDF paint systems. They are the most durable paint system on the market. These can come to up with a 40-year paint finish warranty. The chalk, the fade is off the chart. This is what you want if you're doing a architectural based product. So marine systems. Just because you're next to a salt body of water, or you're over a salt body of water, say you're a boathouse, or say you're a salt shed, right? Very caustic, corrosive environment. Aluminum is a choice. It's more expensive and it doesn't perform as well as steel. You can also use steel in these circumstances if you use a marine paint system. Marine paint system is warranted for either 15 or a 20-year. It has every single color out there. You can be applied over a galvalume, zincalume substrate, a galvanized substrate, which I don't know why you'd use that with the galvalume, zincalume with a warranty, or an aluminum substrate. And the marine paint systems use a high build primer, but you can do this with steel. Now, we're going to go off track again. I'm doing this a lot, this presentation. So let's think back to your materials class, your first year, okay? In rolled form, again, rolled form, not extruded, okay? Rolled form, steel has a memory, okay? So think of your granddad's truck, right? You're at Safeway or whatever, and you walk out and there's a shopping cart that hit the side of his truck, and he goes, not a big deal. You go home, pop off the interior door panel, hammer that back out, and it's like brand new, okay? That steel has a memory. Try that with aluminum nowadays, ain't no way, okay? It's like replace the door panel. So aluminum doesn't have a memory, steel does. Steel also has higher performance characteristics. So if you have to achieve a specific uplift, steel can do that maybe with clips 4 foot on center, where aluminum, you may need them 2 foot on center. So again, in rolled form, there's pros and cons to steel versus aluminum. Also, keep in mind, steel tends to move 1/8 of an inch over a 10-foot stick, okay? So if you have an 80-foot long roof panel, say, I know this is siding, but this will all tie in. If we have an 80-foot long roof panel, 1/8 of an inch in high desert, where it gets hot and cold in the same day, that metal is going to move an inch in either direction as it thermally cycles. Aluminum may move 1/4 of an inch. That's a 2-inch movement. So know that when you're picking these metals. All right, back on track. The cool. This is the magic fairy dust. We've already talked about that. So moving on. So LRV, okay, light reflectance is the visible, LRV is light reflectance, the visible light reflected by a surface, okay? So LRV is how much visible or usable light that reflects from that surface. The higher the number, the more visible light is reflected. That's like glare, right? Typically, lighter colors will have a higher value than darker colors, but texture also can impact LRV. And I wanted to dive in on this because if you have a print, like a Core 10 print or a wood grain print or a metallic and so on, this will all impact LRV. The manufacturer should be able to give you that LRV. Solar reflectance, SRV, measures the amount of total solar radiation. It's different, or infrared and ultraviolet that's reflected from the surface, okay? So SRV is a percentage of 1 to 100. The higher numbers, the more solar radiation that's reflected. So that is your hotel in Vegas that had the rooftop pool and people were getting sunburned really badly. And they're like, I couldn't figure out why. Well, they had that parabolic installation and it's like, it was just taking sunlight and dinging it straight down to the pool. Pool's super hot, people getting sunburned. That's the difference. Visible light versus I can feel this and it's hurting, right? Okay, so that's the first stop. Do we have any questions in anything I've discussed from metal types, movement, paint systems, and so on?
Thanks, Jeff. We have some questions coming in. First question, can you explain more about the no warranty of galvanized substrate versus Galvalume Zincalume substrate?
Yes, I can. So a substrate warranty refers to the bare metal, the base substrate. That is it going to rust, chip, crack, or craze with that coating? It's like, hey, this is going to rust through, is how I think of it. Okay. The substrate coating with galvanized does not carry a warranty by definition. A substrate warranty with Zincalume Galvalume, where you can take that metal, coat it in Zincalume Galvalume 5545, and then put it up on a roof or a wall panel so it has that metal look, has a finish warranty with it. That means if it starts to rust through, you have a warrantable claim. This is in addition to your paint warranty, in addition to your contractor's workmanship warranty, in addition to a leak-free warranty you have from the manufacturer. So substrate and paint are key when it comes to the materials, and oftentimes a good manufacturer will offer them as a combined warranty, a substrate in conjunction with the paint finish. If they don't, they're either buying secondhand, private labeling, or it's a galvanized substrate and they don't offer a warranty. They don't offer a substrate warranty.
Next question, does the backer coat have the same life as the top coat?
Absolutely not. Hey, good question. Gold star, whoever asked that one. Good job. Okay. The back is a polyester coating. That is our bargain basement cheat coating. It's typically not seen, so they coat it with that, right? Top's Kynar. It's exposed to the surface, the elements. It's going to weather well. That's your tough paint system. The bottom, again, and when they go to buy stuff, flat stock from roofing supply houses or roofing supply groups or so on, their paint systems don't need to be Kynar. It could be polyester or an SMP, a silicon modified polyester. So it will not weather the same whatsoever. The net follow-up question to that is typically, what if I want color on both sides? So if I'm doing like an open canopy or something, right? The backside of a wall visible. So if it's going to be weathered and exposed to UV, it should be Kynar. But if it's in a canopy, you just want to see that color, you can coat it on both sides, but that is going to require a second run through the coating system, and it will be a minimum order of, I believe, 1,500 lineal foot of motherwood coil, which is a 4-foot wide coil, which equates to about 3,500 square feet. But you can do Kynar on both sides, but it is a special order. Otherwise, polyester, when you look up and you see the white on a canopy, is fine, but it will not weather the same.
Can you explain the cut edge conditions using single skin metal siding?
Cut edge conditions. Okay, so I think this question is referring to how you cut for a partial panel. So a cut condition is if you have a partial panel. Say you have a exposed fastener panel that's coming up and you don't have a full panel width at the edge. This is an advanced question, whoever asked it. They're 12 inches wide typically. So you have 8 inches. You have to cut that panel in length in order to make it fit on that wall, and you do a cut edge condition. You may not grind or use any grinding method on metal. And the reason for that is because when you use a grinder, it doesn't leave a clean edge. Like if you were to magnify that in, it would look like Velcro. It's just jagged, okay? That doesn't put a clean edge on the substrate. A shearing motion will put a clean edge on that substrate. So if you have this metal that comes in, you coat it with zinc aluminum on either side, right? And you grind it, this edge will be exposed and it won't weather correctly. If you shear it with a shearing motion, it pulls it over and this edge is now coated with the zinc aluminum galvalume, so it won't weather. So in order to maintain a paint finish warranty, your subcontractor must only use a shearing motion when cutting a metal panel. That's a very advanced and good question, second gold star.
Okay, we'll get back to some more questions in a bit. And for now, we'll get back to the presentation.
Okay. This is my least favorite section, so we're going to blast through this, okay? Metal is recyclable and it has a low environmental impact, right? So this one, in a nutshell, they explored cool siding benefits, technology, and infrastructure in a research project sponsored by the California Energy Commission's Electric Program Investment Charge. And they evaluated annual energy costs and emission savings in California in zones 1 to 4. That's our climate zones. They used a program to model the energy. And the findings indicated, this is the key out of all this on here, the findings indicated that cool siding saves energy and money and reduces carbon dioxide in warm climates. It also, this is the important part, it mitigates the heat island effect. So it tends to stay cleaner and so on. What the heat island is if you have siding and that comes in and the sun hits it and it bounces back off into a parking lot or something and it warms the parking lot up. That's the difference I spoke about earlier. So yeah, moving on. Okay, cool sidings. Must have a cool siding in a variety of different applications. Yes, metal can hit lead, green globe, living building. I'll dive in on this in a second. So from a green building certification standpoint, we've done a comprehensive assessment of how 4.1 determines how metal roof and siding products contribute to green certification programs. And although this is based on LEED 4.1 point system, several of the categories in LEED are similar to other green building or certification programs like Green Globe, CHIPS, which I think is collaborative for high performance schools. But depending on the design of your project, metal siding can or cannot contribute. Again, my least favorite section. This part is important. Okay. Living building challenge, which I'm sure all of you are into now, right? It's the new, the greatest, the best. Okay. For the living building challenge, for the products to fit into the materials petal of the living building challenge, to be eligible, a manufacturer must disclose 100% of ingredients to 100 parts per million of the materials and chemicals on the red list, okay? That second prong where it says today metal siding panels are able to meet is kind of misleading, and here's why. Metal siding panels coated in zinc aluminum, as I've spoken about earlier, galvalume, with a clear protective resin, they meet the LBC red list free criteria because we can disclose 100% of the chemicals and ingredients in there. This is a standard offer, no extra cost, and it looks like metal, right? There's no paint. It's just the zinc aluminum galvalume, or 60G90 if you go galvanized. But this can meet the materials petal. However, any paint, okay, any painted panel will not made it, okay? And here's the reason why. There's a massive hesitation by all the coating manufacturers, PPG, Sherwin-Williams, to provide their proprietary information on their paint formulas. It's like, hey, we're all competitors. Let me give you my secret sauce, right? There's no way KFC is going to disclose their secret to, Colonel's chicken, right? So that's what's happening here is you have to disclose what's going on. And they're like, no, we're not going to do that. I'm not going to give you our secret sauce so our other competitors can hit this. So this is a huge issue. There's progress a little bit, but I wouldn't hold your breath. I don't think it's going to happen. All right. Any questions on that before we jump into something way more interesting?
Okay, we have some more good questions coming in here. What color or colors tend to fade faster, Kynar or non-Kynar?
Non-Kynar. So here's why. Kynar has a much higher chalk and fade, which you can call out in the specifications. Kynar's chalk and fade is 800 delta units. It's fantastic, right? Polyester or SMPs, I like SMPs much better than polyester, right? SMPs will fade faster than Kynar, and polyester will fade faster than both SMPs and Kynar. That is, again, one of the reasons why I say when you specify sheet metal flashing and trim, you should specify it should be sourced from the same as the manufacturer of the metal panel so it doesn't fade differently. I've got photos. I love horror photos. If you have any, send them my way. Of trim, rake trim that's running down the side and some gable trim. And it's like the panels look fantastic and the trim's like a different color. And it's because it was sourced with a different paint system. So Kynar weather is the best.
How do you control batch to batch color consistency?
Duh. Another gold star question. Okay, you guys are on point today, huh? So some paints are batch sensitive and some are not. So standard colors like your Regal White, Colonial Red, Royal Blue, Emerald Green, and so on, that's like going to Home Depot and you stick the gallon of paint under the machine and it turns and it measures out the exact amount and it's done. It's all computerized, right? It's not batch sensitive. There are batch sensitive colors. These are your metallics, your prints, and any overlays. And what I mean by overlays is we do have some colors like vintage that the panels run through on. It's like a screening process with a t-shirt, right? The first pass is yellow and the next pass is blue and the next pass is green. So when you have overlays on a paint system, that's batch sensitive. So again, your metallics, your prints, like your Corten, your wood grain, your rustics, textured or your vintages, those are all batch sensitive and you can try to control and get it the best you can, but one might be 1 degree darker or 1 degree lighter. So if you're doing a paint system that is batch sensitive, order all of your coils at the same time. Order more than you need for your panels, your siding, your flat stock, all of it. Order it all, because if you have to go back because you shorted yourself, fingers crossed it's going to match up, because it may not. So there's batch sensitive and non-batch sensitive. Good question.
Okay, let's do one more. What's the average lifespan of the exposed fastened rubber gaskets of the screws?
Okay, that is a loaded question, whoever asked that. I'm going to jump into that next. Okay, so what this question is entailing is a exposed fastener panel has fasteners that are run through it by definition, right? Exposed fasteners. They have a neoprene gasket or a washer that seals that screw head when it goes in, and that gasket weathers. The amount of time that it weathers is going to depend on its exposure. Is it on the warm side? Is it heating up and cooling off and heating up and cooling off and heating up and cooling off? Because here's why. Metal moves, right? I told you metal moves 1/8 of an inch over steel, over a 10-foot stick, and up to 1/4 of an inch on aluminum. As it's moving, that panel wants to expand and contract, and that fastener is going to go back and forth and expand and contract too. So think of a nail in a fence. You've walked by your fence after it rained, and you're like, dude, the wood expanded, and this nail backed out. I almost caught myself on it. That's what happens with exposed fastener panels as well. So it is a maintenance item. My answer to you after all that, it's a maintenance item with exposed fasteners. They could last 20 years. They could last 5. And it is depending on how much movement and how much weathering that fastener is going to have. I've seen fasteners that are seated 20, 25 years down the road. I've also seen fasteners that have backed out after 2. So it is a maintenance item, but that washer, once it fails or the fastener backs out, how you fix that is you back the fastener out 100% and replace it with an oversized fastener. So if you have a 10, you go to a 12.
Okay, let's get back to your presentation, Jeff.
All righty. Learning objective 3. Yay, here we go. Exposed versus concealed. Okay, exposed fastener by definition is exposed fastener, right? Surprise. Exposed fasteners will have 3 things in common. Number 1, fasteners are exposed. Number 2, they rely on laps and sealant for waterproofing. If it's on a roof, you shingle down. If it's on a wall, you shingle over, right? Laps and sealant for waterproofing. As you can see in this one right here, as it laps over, there's a bead of sealant and it laps. That's a waterproofing layer. Number 3, exposed fasteners are all nestable. What do you mean, Jeff? Good question from the ether. Whoever asked that. What I mean is they all ship on a pallet. They're nestable. You can alternate them back and forth. They rely on laps and sealants for waterproofing, so they have to be able to lap. That's why you won't see right angles, right? Because you can't fit a right angle inside of a right angle. It's the same width. Every exposed fastener panel will have a slight angle to it. I don't care if it's a sine wave. I don't care if it's a trapezoid. I don't care if it's a box rib. I don't care if it's a V. They all install the same. Okay, from your 1800s old-timey gold sine wave to your new box panels, they all install the same. They all have exposed fasteners, laps, and sealant for waterproofing, and they're nestable. All right, so again, doesn't matter which panel you use, which type, pick one, they install basically the exact same, okay? Now, to put this in perspective, we can get out there with a 6-pack of beer and a pizza, and we can put exposed fastening panels up. It's not tough, right? It's like line it up, make sure it's straight, sealant, run some fasteners through. Concealed fastener panels are much more nuanced, and I'll jump into that in 1 second. So this is what exposed fastener looks like up on a structure, their roof and wall. If you're using them on a roof, they are limited to 3/12 slope if not lapped and sealed, or 1/12 sloped over conditioned space. Of course, this is over conditioned space. 1/12 slope if they're lapped with sealant or solder. Some examples of what your exposed fasteners look like. Now, if you look at this here, we have sine wave in a box, sine wave on your left, a box on your right. More traditional box there. So there's a lot of different options for these. Okay. For concealed fastener panels, it is the opposite of all of that, right? They do not have exposed fasteners. They rely on clips and occasionally direct attachments, but usually clips so they can move. Thermally cycle within that clip. They are not don't rely on laps and sealant for their waterproofing. They rely on a male-female engaging leg. And number 3, they're not nestable because you can't fit right angles inside right angles. Like if you take in the bottom left, there's a box that goes 2 inches up, 2 inches across, 2 inches down. You can't fit that same panel inside that same panel, right? Because it's the same width. It won't fit. So concealed fasteners are more expensive. We cannot install these. Right? We couldn't get out there with a 6-pack of beer and a pizza and put these up. These are much more nuanced. Also, it's more expensive. Okay? Generally speaking, high level general speaking, okay? Concealed fastener panels are 1.5 to 2 times the cost of exposed fastener panels when you take into consideration material and labor. All right. These are super cool though, because you can intermix profiles, right? You can have one series that has the same intermixing leg and you can vary profiles and do all kinds of different stuff. It's cool. Also, you can lap them and do cool things like on the left. On the left here is a standing seam that has been cut with a joggle cleat. So you get my camera correct. A joggle cleat looks like that, right? It engages like that. That's a standing seam panel that's been cut to a 4-foot length, engaged with the next below panel, and then a continuous batten has been run down the side of the panel to make it look like a shingled fashion, but it's a standing seam panel. It looks fantastic, right? So some more examples here. This is varied profiles. You can intermix profiles back and forth. You can do different reveals within series. I talked about this earlier. This is expansion and contraction, steel versus aluminum. Forgot this was in there. So metal likes to party, right? Metal is your party animal when it comes to building materials. It likes to move. So you have to be able to accommodate the thermal expansion and contraction of your metal panel. All right. So this one here. So that question that was asked earlier from the individual that got my gold star about the fasteners through exposed panels. Over time, because again, if you think about it, that profiles through fasten, so it's permanently fixed, right? There's no clip that it can move within. It's thermally pinned. So what happens is every single repetition in that corrugated panel, again, I don't care if it's a sine wave or a box or a trapezoid or whatever, every corrugation acts as a little spring to move just enough where those fasteners go through. So that's how that happens, how it accommodates thermal movement, but it is pinned. So the fastener that goes through may stretch or tear or back out eventually. Again, that's your maintenance item. Go through and check all the fasteners, right? They may have to be replaced or with an oversized fastener, or it may stretch and tear. That is just something you have to accept. It's part of an exposed fastener. But they're really easy to fix, very easy to replace. If you have a concealed fastener panel and someone kicks a wall and puts a big dent in it, you may not be able to take it off. It may be every panel to the side has to come off so you can hit that one, right? With an exposed fastener, it's like unzip, new panel in, zip some fasteners, done deal. So last one is the ASTM E283 and the E331. That is the exposed fastener panels, water infiltration and air infiltration. Many of them have been tested and approved through ASTM. Okay, so laps, again, they rely on laps and sealant for exposed fasteners for their waterproofing. So the first is a traditional lap where one panel rests over the adjacent panel. This lap is commonly found in exposed fastener siding panels all the time. The field applied lap sealant is required to keep the side laps watertight though. Okay, concealed fastener panels. This is a direct fasten, not a clip. If you look, there's a fastener through that leg. You can also have clips, right? So this one is an integral seam, utilizes a male-female engagement, and the panel attachment is achieved either from directly fastening through the nailer strip on the female leg or with a clip attachment, which I prefer personally, so the metal can move, because if you fasten here, the panel's pinned, right? So this is my preference. I think these look the best. There's more options, and you can use clips. So the hook seam is two reverse rolled hems that positively engage one another, right? So the first panel goes down, you put a clip over it, adjacent panel above engages and overlaps, and that's how you shingle up. These panels can thermally cycle. They can move, they can slide within that clip. These clips also provide fantastic pull out and wind uplift, right? They perform to a much higher level. Also, you can use a flush clip or a standoff. So you want to do a rain screen type system, but you don't want to spend a bunch of money on hat channel. Well, we can elevate that panel off of the substrate with a standoff clip. So this is my preference also because with concealed fastener panels, there's different profiles to choose within this same clip engagement. So you can choose a 6 up, 6 down, 4-4-4, whatever orientation, and mix and match, and it looks just very aesthetically pleasing. This right here, what is this one? This is just showing an exposed fastener panel versus the concealed. We're going to move past this. Questions on concealed versus exposed fastener panels.
Okay, we have some more gold star questions coming
All right.
in. If a panel in the middle of a wall is damaged, how do you replace a panel without removing the entire surface? Is this possible?
It is possible, panel dependent. If you have a through fastened panel where you run fasteners through, you can pull the fasteners out, slide that piece that's damaged out, slide a new piece in, and refasten. Okay. If you have standing seam on the walls with certain standing seam types, you can pop the batten caps, pull the panel, and replace the batten caps. If you have a directional male to female engagement panel, which is the majority of concealed fastener wall panels, okay, the large majority of concealed fastener wall panels has a male-female interlock, you are kind of upstream without a path. You got to remove everything to the side, or you have to have a fantastic sub that knows the nuance of being able to pop a panel out mid-panel run and replace it. So my answer is yes, no, maybe, depending on what panel it is. One thing that I want to tee off on this question to keep in mind is if you are specifying metal panels within the interaction and human element on a school, a commercial building, someone will go outside and lean up against your wall and have a cigarette or take a phone call. A kid will kick a ball against it. Someone will get into a fight with a significant other and punch the wall. Okay, there's that human element. Because of this, either go real high gauge, like 22 minimum for that wall panel, or have a profile in it, because a flat panel will, number one, oil can more, have a higher propensity to oil can, and number two, it'll dent easier. So if you have a flat flush panel where it's just 12-inch wide panels that make a flat wall, that one, because it's raised by an inch behind it, will tend to concave more, right? Whereas a box rib won't. So a profile and a gauge is an absolute must at the human interaction zone.
Okay, let's do one more. What fastener do you recommend if you want to replace a number 14 fastener on an exposed fastener roof panel?
Okay, so they also, I knew I was going to get this. Again, well done. After a number 14, it's hard to bump them up. They do make oversized gaskets. So I wouldn't replace a number 14. I would start off with a lower fastener by at the install, which most manufacturers will recommend. It's typically 10, 12s. If you're getting up into the 14 range, replace the panel. I mean, it shouldn't be a long panel run. They do make oversized gaskets, but you are correct. You will hit a glass ceiling, a tolerance where you can't go higher.
Okay, in the interest of time, we will take more questions at the end, but for now, we'll get back to Jeff's presentation.
Okay, let's see how fast I can get through this. What time do we have? Oh, we have not a lot. Single skin metal sidings can be installed vertically or horizontally. Doesn't matter if they are exposed and or concealed. They can go both directions. Okay. What's this one? Vertical applications. Got you. This one is panels can be laid left to right or right to left. There's some leeway in this where you don't have with others. This one is showing how not to install. Horizontal applications are a bit different because when installing your seamed panels with a male-female leg, they are intended to be installed from the top of an elevation down due to its seam configuration. If they're installed bottom up, the female leg can trap runoff from the ring, which can compromise the weather tightness, right? You can see how one of those will catch water and one won't, right? Okay. So your traditional side lap seams and hook seams are just the opposite of the integral seam panels. The traditional side lap and hook seam panels are required to be installed from the bottom of an elevation up, which will allow runoff over the lap. Installing from the top down will compromise your weather tightness. So pay attention to when you're installing the different panels. Okay, what can they go over? Lots of substrates. Keep in mind, metal will follow the substrate it's being installed over. So make sure your substrate is true, level, and plumb. You can also install this over like rain screen systems, like over like an exterior rock wool type board or polyiso. They can rest on that and be installed through that into the substrate, or you can install hat channels through the rain screen to elevate the panel off. If you want to get involved in rain screens, that is a rabbit hole I would love to go down with you. I like those. So reach out to me offline. So fasteners. I'm not going to spend too much time on this. Fasteners are size and type are going to be defined by the panel, the clip, and the substrate that's being utilized. Always, 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 always put manufacturer's suggested fastener on your specifications. You as an architect, I'm going to go off track again here, have this interesting area where if you don't specify enough, if you're way too high and it's not defined, all your work's going to get VE'd out by some sub that does cabinets one week and metal panels the next. If you dive in too far and you specify too much, now you have the liability. And what I mean by that is what if you screwed up the fastener? What if you messed up a super specific trim condition that metal subs take for granted because it's so simple, like a ridge, right? What if you mess that up or you specified the wrong fastener? Now the liability is on you and it's a change order. So you want to not be up high where you can have all your work just go by the wayside, and not too specific to where you take on liability. You want to be right in the middle where you don't have liability and the liability is on the sub. Find the fastener for my project that is the correct length, the correct size, and going into the correct, has the correct point type for the substrate. Manufacturer's suggested fastener. Take that for what you will. Okay, evaluation reports. Not all evaluation reports all the same. Real quick, UL is different than your Intertech, which is different from your ICCES or your IATMO UES. ICC and IATMO are virtually interchangeable. So it starts with the certification body. They develop the criteria and you go through. So IATMO UES is currently the only known certification body that has an evaluation criteria for metal siding. ICC is not. So IATMO is the preference for metal manufacturers as compared to ICC. However, IATMO and ICC are virtually interchangeable. Okay. This is what your evaluation report looks like with your tables and your fastening patterns. If you focus in on the right side, I'm going to walk you through how to read this real quick. The inward positive is very simple and straightforward, right? The negative is more complex. So you start at the top where you pick your panel and your gauge. If this is a standing seam, it'll have a panel width and a gauge. So standing seam 12-inch will be different than standing seam 16. Your through fastened will be different. We'll have one page, but your panel that can be direct fastened or clip attached will have different. So make sure you're on that correct page first. Second, go to the far left and pick your substrate. What are you going to go into? Grade 50, grade 33, plywood OSB, or dimensional lumber, right? Let's pick plywood and OSB, right? Everything else on this page now disappears except for that one, those 3 rows of plywood OSB, okay? You go one column over. What are you going to go into? You're going to go into a 1/2 inch, 5/8, or 3/4. Okay, let's pick 19/30 seconds, which is your, everything else on this page now disappears except for that one row, okay? So that's how you move over and you read these reports. Now, one thing that I do want to touch on is UL is not the same as your ASTM tested IATMO or ICC. And what I mean by that is UL is test pass fail. Okay. ASTM testing for wind uplift is a push to failure, which is why you can extrapolate those values out and apply them to the UES reports like IATMO and ICC. Here's what I mean by that. You have a family member going into surgery, okay? Do you want a surgeon that had a pass fail on their boards and their exams? You know, oh, 70% plus, you get your license. That's the realtor's exam, okay? Did you pass or did you fail? Or do you want the ranked surgeon, best in their class, to work on your loved one? I know what I would want, right? That's ASTM and the testing IATMO and ICC. It's push to failure. UL's pass fail. The other one is a ranked, which is why we can get those values that I showed you here and extrapolate them out. So this is what your outward loading will be at 2 foot and 3 foot and 4 foot and 5 foot on center, right? For standing seam, for example. So these are always going to use the ASTM testing. Okay, underlayment. On a wall, I'm not going to make a recommendation. Generally speaking, I see a Tyvek Type 2 or similar, which is used as a moisture barrier on a roofing type application. I generally see a 40 mil peel and stick vapor closed, which is a 0.03 to 0.05. So it won't escape. This is going, so moisture won't escape and underneath the metal roof panel on the roof. Walls are a different story. There is so many paths that we can take here. This slide is just super high level. If you need help selecting a vapor barrier, an air and water barrier, a moisture barrier, which are now combined into one, most of the time we can reach out for your building specific requirements, because we have to take into consideration the building type, occupancy, location, exterior wall type, all that, right? Okay. Citing underlayment, this is your different vapor ratings. Class 1 is less than 0.1 perm, which is vapor impermeable. A class 2 is 0.1 to 1, which is semi-impermeable, and anything class 3 is considered vapor open. So these are the different vapor barriers. Class 1 with a 0.03 to 0.05 is used on roofs, and typically class 2 is used on walls in about 90% of the applications. We're going to skip past that to get to details so we can hit questions. Okay. These are the typical base trim details for a vertical and horizontal application. Careful consideration should be taken to ensure that all base conditions are installed above grade to avoid any potential issue with standing or ponding water. And also, if you have any acidic, not acidic, what's the word for cementitious? Corrosive? No, I'm going to add structure. Cement and metal don't mix. I'll think of that word down the line. There should be a 1/4 inch gap required between the base flashing and the bottom of the panel to allow for weepage. And material should also avoid direct contact with mortar or concrete, as I just touched on. Aluminum zinc should not be used on or in around concrete or mortar. Alkaline, that's the word. Alkaline. It's an alkaline environment. Glad we added structure to that. Okay. For vertical applications, note that the detail and design perspective, the siding and the base trim is sloped away from the building. This photo shows what a cut panel edge termed into a J trim at the base of a siding can lead to panel edge corrosion. J trim used at the base of a siding will trap moisture and act as a gutter, which can lead to premature panel deterioration. So slope it away from the building. It's absolutely critical. Parapet cap. Parapet cap details. Again, this one is not going to be your ANSI SPRA ES1 compliant coping, but this is what's typically used. If you need ANSI SPRA ES1 compliant coping, reach out to me. I can talk to you on that. That there's some slope built into the parapet cap here to prevent ponding. The exposed exterior of the parapet is concealed, fastened, and attached to a trim cleat, which allows the parapet cap to show no visible fasteners on the exposed side. Only the interior side is fastened with an exposed fastener. It's not possible to engage both sides of a parapet cap with this unless you go to a spring chair and ANSI spray ES1 coping, which is a world of hurt a lot of times, but this is what's typically done. So these are typical inside and outside corner details which utilize flat trim pieces that cover the factory cut edge of the profile. These trim pieces are typically attached to the high ribs of the panel with blind rivets, 12 inches on center, to minimize the appearance of the exposed fasteners. Profiled closures installed between the panel and the corner of the trim to prevent wind-driven particulate and pests. Those are your neoprene closures you shove up in there that seal the corners with the profile. Every one will have these. A sine wave will have a sine wave profile, a box will have a box profile, etc. Because I am going to get a question on this, is it possible to do a sealed, mitered, welded corner? You can put in, yes, it is. There are a couple companies that will manufacture these. You can get the material roll formed, sent, and then you can send it out to have mitered corners made. It is expensive, but it can be done. Inside and outside corner conditions will give a vertical line break, as seen here. The size of the corner trim can be adjusted. The typical is like a 4x4 or 6x6, but it can be adjusted. Another option for the outside and inside corners are what's known as a profile or mitered corner. Again, I talked about this. This is what it looks like. They're typically only used on horizontal applications because you can't do them vertically, but this is possible. There are a couple companies that will do this for you. Okay, typical window detail. This allows for a proper seal between the header flashing and the opening frame, just like before. Keep that 1/4 inch gap. Put that flashing back there. This is a jam condition, right? Yep, jam. So this is the trim installed prior to what is being installed in the, in the opening. The panel is then tucked behind the trim and secured with rivets at 12 inches on center. Profiled closures are used to seal the gaps by the panel. Straightforward. Window sill, we're going to have the same thing. In the interest of time, I'm moving on. This is, soffit transition. Okay, this one's cool. This condition is a siding panel or fascia panel to soffit transition. It's handled the same as a typical base condition with one exception. This is a major exception. The cover trim is an adaptation of the base trim flashing with an extra long return to allow for an overlap onto the desired soffit below. The placement of the cover trim should be considered very carefully, as a sufficient gap will be needed to account for the thickness of the soffit that's going behind it. And sequencing of this is important as well. It would be soffit material first, then the cover trim, then the siding or fascia. Okay, these are siding detail penetrations. There are no details for stuff like this. There's so many hose bibs, conduit connections, saddles. All this is going to rely on the skill of the installer. I've got a host of photos of what's been done previously if you'd like to see. Again, skill of the installer. There's just too many to account for. End laps for the nestable products are very simple to achieve. The panel just laps over the other. Again, this is known as nesting. Nestable products are exposed fastener by definition, right? Concealed fasteners utilize a nestable end lap due to the panel playout. But these types of laps are between 3 and 6 inches, and sealed in the lap is a bead of gunnable non-skidding butyl. This is what gives it that waterproofing protection. How are we doing on time? I'm going. Unlike the nestable profiles, the non-nestable profiles require a through fastened trim piece to achieve the panel end lap. Okay, through fastened trim piece. This may work or it may not, but with aesthetics, generally speaking, it gives a nice break, right? Flashing lap lines can be coordinated in a way so it matches the siding and the aesthetics of the building. This is a vertical trim lap line shown on this guy. This is a butt splice on an application where different size and color profiles are going to be used on the same elevation, or where the project aesthetics won't allow for an end splice to be used. That's that photo, and I think we're done. Let's get to questions, right? Oh, this is what I was talking about earlier. The panels have different profiles that interact. This is all different in sequence. They're all different types of profiles, but they all interlock with one another, providing a great aesthetic look there. We made it. 1 minute to spare. Thanks for staying with me through that ride of speaking in that last section.
Okay, we have a few final questions.
And
The
I can
panels.
stay on for a little bit longer if there's more questions as well.
Okay, sure. The panels shown are all relatively narrow, for example, 6-inch to 12-inch ribs. Are there wider single sheet products, for example, 24-inch flat panels?
Good question. Generally speaking, the large majority of manufacturers roll form concealed fastener panels in 12-inch widths. I would venture to guess 96 to 98% are all 12-inch wide. You can make it look 24 inches by putting the same panel adjacent. You will have that line, which won't be a reveal unless you get close. There are some manufacturers that do manufacture 24-inch wide panels. Those are one-offs and more rare, but yes, they do come larger than 12 inches. However, most of them, 12 inches.
The detailed drawings show the clip fasteners into the sheathing. Should they extend all the way into the metal stud?
So somewhat of a difficult question to answer because it depends on your sheathing, right? If it's going into a Den's deck or a Den's glass on the exterior side, yes, it must go through into something that has pull-out value. I want you to think of hanging a mirror in your home on sheetrock, right? As soon as you put it up, it's going to get pulled out. But if you find a stud, it'll have pull-out. So the answer to that question is if the substrate does not have pull-out, like a polyiso or a rock wool board or a Den's glass board, it must go through to a stud that has some sort of pullout, whether it's metal or wood, or if your sheathing is wood that has pullout, you're okay. So yes and no.
Okay, is there a recommended panel thickness relative to panel width to avoid oil canning?
Ah, there it is. I knew someone was going to ask. Oil canning is defined in SMACNA as a repeatable, measurable result of the roll forming process. Okay, that's what SMACNA defines it as. The roll former was putting a blip into the metal. Now, how we all look at oil canning, me included, is if I walk up to a building and put my hands on my hips and go, that doesn't look straight, right? So oil canning, from that perspective, relies on everything from fabrication to crating to shipment to unpacking to was it handled correctly, to hot side versus cold side. Is it thermally pinned with a screw or a fastener? What is the gauge of the panel? What's the profile of the panel? What's the color of the panel? All this comes into play. In order to minimize oil canning, you want a thicker gauge. If you're doing wall panels in a concealed fastener, you should use 22 gauge only. Don't consider 24 or higher. It should have a profile. If you're doing a flat or a flush panel, go thicker gauge, okay? Metallics and darker colors tend to show oil canning more. And then what really messes this up are rivets, because a rivet, it pops a piece of trim on, puts a point of fixity there. So if it's done incorrectly and it pins that panel's going to oil can. So my answer is the thicker you can go with a profile, you will minimize oil canning substantially. If you have a flat piece of metal and it's thermally pinned and it's light gauge, it's going to oil can. That's
How do
also
you
why
determine?
12-inch wide panels are preferred over 24-inch. Sorry.
Okay. How do you determine spacing of end splices?
Okay, so panels can be roll formed in different lengths. So certain panels can be roll formed up to 10 feet. Some might be 25 feet in length. End splices are really up to the design intent of the designer. I've seen end splices that are spaced on par with windows or floor breaks is typically speaking, but it will be defined from the maximum panel run length, and that's going to be dependent on your manufacturer. What I can tell you is most of the concealed fastener panels that my company manufactures at a 22 gauge thickness will give you a 25 to 30 foot maximum length panel run. Those are more difficult to handle as well because you need more installers. So shorter lengths are easier to put up, but it can go up to 25 or 30 feet.
Okay, and this isn't a question, but we've had a few comments coming in thanking Jeff for an excellent
Thank
presentation,
you.
engaging and entertaining as always. So on that note, that's all the time we have for today. If you need to reach out with any additional questions, Jeff's contact information is currently up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the webinar within a week. Once again, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folders. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thanks again, Jeff. Thanks everyone, and have a great day.
Bye all.